Hey, what's up, guys? Welcome to Geometry with Mr. G again. And today we're talking about lesson 4.3, 4.4, rotations. The key word for rotations I want you to think of, spin, right? That's our key word for rotations. We're spinning, okay? So starting with our rotations here, you need to make sure you have your cheat sheet handily available, the transformation cheat sheet, so that we have the rules for each of these transformations. So let's look at the first one. It says 180 degrees counterclockwise, right? Again, remember clockwise is spinning towards the right and counterclockwise spins to the left, right? So you might see this also as CCW, counterclockwise, just a shorthand. I went ahead and drew all my T-charts and put all the points for the starting, for the pre-images, right? The starting image here. I went ahead and put all the pre-image points or the original points. So go ahead and pause the video, do your T-charts, maybe add these points, it'll help speed it up a little bit. So for each one of these, I'm going to use red. As you can see, the red is where my pre-image points are, the starting points, and I'm going to use blue for our rule. Notice, first off, that each of these graphs, right, the graphs are going by twos, right? The graphs are going by twos. So it's 2, 4, 6 for the X and the Y axis here. So I'm going to switch to blue. Let's figure out a rule. So remember, a rule is what we put on the right side, whatever the rule is. If I'm looking at my cheat sheet, the rule for a 180-degree rotation is negative X, negative Y, right? Negative X, opposite Y. You can think of it in different ways. And in a prior video, you may have seen some people use AB instead of XY. Don't let that confuse you. It's the same thing. I like to use XY to stay consistent with what the cheat sheet shows you, but it's the same process. So let's get our points here then. J prime will be, so the X changes sign, so negative 2 becomes positive 2, and the Y changes sign, so that positive 4 from J becomes negative 4. So there's J prime. Let's look at K prime. That'll be 5, comma, negative 1, right? I'm just changing the signs. L prime, 2, comma, 2, and M prime, negative 1, comma, negative 1. That's all we do for that. You change the signs. Let me go ahead. I'll pause the video to do graphing as well. So again, I went ahead and paused the video and went ahead and put my graph there for the image, right? The image is the final picture. So I'm going to do that for the other ones as well. Just kind of pause, graph the pictures. If you need to, go ahead and pause the video, plot your points and label your points, graph the final image, right? All right, so moving on to the next one. I've got a 90 degrees clockwise rotation. So you might see this sometimes as CW for clockwise. And we look at our transformation cheat sheet. You'll notice that the rule for a 90 degrees clockwise rotation, which is the same thing as a 270 degree counterclockwise rotation, the rule is Y comma negative X, right? That's our rule for this one. So R prime would look like this, right? The Y is now coming first. The Y value comes first. Well, the Y value from R was 0, and it doesn't change, right? It stays the same, so it's just 0. And then the X value comes next. Well, the X value from R was negative 4. But you'll notice here we have a negative, right? So that negative 4 is going to switch signs, so now it's going to be a positive 4. So there's R prime. Let's look at S prime, okay? Take it slow again. Y comes first. Well, the Y value for S is this 5, right? So 5 is going to come first, doesn't change. Next is your X value, which from S was this negative 1 here, and it's going to change sign because there's a negative sign there, so it's a positive 1. And then T prime. So the Y value comes first, which is 1, doesn't change sign. X value comes second, which is negative 5, but it does change sign, so it's going to be positive 5. And there's T prime. I'm going to go ahead and pause my video and plot these points. After plotting this, remember the graph's going by twos, right? So it's a little weird for some of these. But after plotting it, you should have something like this. R prime, S prime, T prime. Cool. So let's look at the last one. 270 degrees counterclockwise. Which is actually the same thing as 90 degrees clockwise. So the rule is actually the same for this one. It's going to be Y comma negative X for this one as well. So let's look at this. We got A prime is going to look like this. Y comes first, so the 4 is going to come first. Then the 1 comes next, but there's a negative here, so it's going to change sign, so negative 1. B prime is 3 comma negative 4 then. C prime, 1 comma negative 3. And D prime will be 2 comma negative 1. Right? Just changing the sign of all those X values. Cool, and then I'm going to go ahead and pause the video again and graph this final image. So make sure that when you're graphing, you go ahead and label those points. Make sure you put the primes there, right? Show that that's the transformed image, right? And that's what it should look like for quadrilateral ABCD in this problem. Okay, cool. Now we're moving on to what we call composition of transformations. Now we call this a composition because keyword here, composition, kind of represent or means two or more, right? Two or more things happening. And all of these examples you're about to see, we're going to have two or more transformations, right? So for the first one, we're going to have the first thing is going to be a reflection. So I'm going to put a 1 there. That's the first thing we're doing. The first transformation is a reflection over the x-axis. And then the second transformation is a rotation of 180 degrees. And I'm going to show you how we do these when there's more than one, right? I'm going to go ahead and number all these, right? So 1 and 2, first and second, right? Make sure you do them in order. First, second. It does matter sometimes which ones you do in order, so it's just good practice to always do them in order as you see. I'm going to go ahead and write my T-charts, pause the video for that for just a second. So I went ahead and drew my T-charts here, and you'll notice the T-charts are a little different, right? I call these double T-charts. And it should be pretty explanatory as to why we have this now. We have a double T-chart because we're doing two transformations for each of these, right? So the middle column, right? The first column is our the pre-image. The first column on the left is our pre-image. That's our starting points. The middle column will be the first transformation. And then the second column will be our image, or the final, right? The final transformation, the final image there. So let's go ahead and do this first one together. The first one has a reflection of over the x-axis for the first transformation, and your rule for reflection over the x-axis is x negative y. So the x stays the same, your y values will change sign. So we're going to have -4, comma, -4. And then we have -1 because the x stays the same, and your y values change sign, so that -1 becomes a +1. Those are our new points. Now, something that's very important that I like to do in my classes is once you're done with the first transformation, go ahead and let's cross out that first column. We're now done with that first column. Those points are no longer points that we're using. We've transformed. We've done the first transformation. We now have new points, a new starting point, right? These are our new points right here. So this is what we're going to use to perform our next transformation, which will be our final image, right? Our image here. So then we have, okay, the second transformation is a rotation 180 degrees counterclockwise. The rule for that is -x, -y. So then our M prime, or our final image, M prime is going to be we're just changing the signs for both the x and the y value. So 4, 4. And then for N prime, it's going to be 1, -1. Awesome. I'm going to go ahead and plot that. After you plot it, so look something just like that. So there's our image. Right, we have our pre-image, which is Mn, and our image, which is M prime, N prime. Cool, let's do the next one. So on the next one, we've got our starting points, M and N. Again, that's our pre-image. Our first transformation is a rotation 90 degrees counterclockwise. The rule for that will be -y, x. -y, x, right? So that means we're switching the y and the x values, right? The y will come first. The x will come second now. And the y's, right, the y's are going to change sign, but the x's will stay the same. So our first point will look like this. +1, right, the -1 is going to come first, but the sign switches, so it's +1. And the x value will stay the same, remain the same, -2. For this point, we're going to have -1, 3. Now, if you remember, after we're done with that first transformation, let's go ahead and cross out our first column. We're done with that, never using it again. And now let's perform our second transformation to figure out our image. So the second transformation is a translation. Remember, the rules for translation should be given to you. The rule here is x +2, which means we're going to the right 2 units, and y -3, which means we're going down 3 units. So I'm going to plug in all these points here. So again, we plug in the 1, right? This 1's going to go plugged in here. So 1 + 2 would be 3. And then we plug in the -2 here into y. -2 - 3 would be -5. So there's M prime, 3, -5. Do the same thing for the next point to get N prime. -1 + 2 will be 1. And we have 3 - 3 would be 0. So there's that point. I'm going to go ahead and graph this now. And there's our image, M prime, N prime, right? We're dealing with line segments here, right? Segment M prime, N prime. Cool. That's our second one. So let's look at the last one here. This time we've got our first transformation is a rotation of 270 degrees clockwise. Now again, 270 degrees clockwise is actually the same thing as 90 degrees counterclockwise, which we just did on the prior problem. So it's going to be that same rule here of negative y comma x. That's our rule for this one. So again, we're switching the x and y positions, and the y will change sign. So negative 4 comma 3, so that the x value remains the same. And down here we're going to have negative 1 comma 3. So we got those two for our first transformation. After the first transformation, we're going to go ahead and cross out that first column. We're done with that first column. Let's go ahead and apply our second transformation to figure out our image, right? The second transformation is a reflection over the line y equals x. Now the rule for that, if you look at your cheat sheet, is y comma x. So all we're doing is switching the y and the x value. So now we're going to have the 3 is going to come first, and then negative 4 will come second. And then that's for n prime. So for n prime, we're going to have the 3 comes first and negative 1 comes second, right? There's no changing of any signs because it's a y, the y and the x doesn't have a negative in the rule. There's no negative sign in the rule. So we don't change the signs. All we're doing is putting the y value first, followed by the x value second. So I'm going to go ahead and pause the video and graph our image. And there you have it. That is our segment m prime, n prime, right? The image for this composition of transformation, right? Again, we call it a composition of transformations because we have 2 or more transformations occurring to get our image here, our final image. Awesome. All right, next page. Okay, welcome to the back page. So real quick, let's talk about a keyword here, rigid motion. You may see this on an upcoming test, so this is important. A rigid motion is a motion where the shape does not change, right? And hopefully we've been talking about this in our classes, but a translation, a reflection, a rotation, right? This box right here talks all about, those are the 3 examples of transformations that are rigid motions because the shape does not change. Now the location of it changes, but the shape itself does not change. So another name for this is congruence transformation, and that should be pretty obvious or pretty easy to understand because remember, congruence, that means same shape, stays equal, right? So it's a transformation. The shape is moving to a new spot, but it's not changing the shape. So that should give it away, but that means a dilation, right? A dilation is not rigid motion, right? And if you're wondering why, you'll see in your next lesson, but a dilation is not a rigid motion because the dilation either makes the shape bigger, it gets bigger, or it gets smaller. So the shape is actually changing. The lengths of the sides are actually changing. So dilation is not rigid motion. So that's it for that. Let's look at symmetry. We've got different types of symmetry: line of symmetry, point symmetry, and rotational symmetry. I'm going to go ahead. We're going to talk about these examples here. In your classes, we're going to go over a little bit over lines of symmetry and rotational symmetry. I'm going to work over here, show you just an example of lines of symmetry and how this works. So when I'm looking at this first shape, line of symmetry, I would be thinking of lines of symmetry. I'd be thinking of like a mirror, right? Or reflection. So it's the same on both sides is what I like to tell my kids. It has to be the same on both sides. So for example, right, that would be a line of symmetry because it's the same on both sides of those, both sides of that line. I could literally fold that shape in half, and it would fold. Both sides would perfectly fold on top of each other. There's actually another one here, horizontally, right? So this one has 2 lines of symmetry, right? This one has 2 lines of symmetry. Let's look at the next one. This one can be kind of tricky because it should be pretty obvious to everyone. Hey, we got 1 line of symmetry here, which I agree. But if you rotate the shape just a little bit, you should see we also have a line of symmetry here as well, right? Then we also have a line of symmetry here, line of symmetry here. That's 4 lines so far. A line of symmetry here, that's 5. And a line of symmetry there, and that's 6. So there are six lines of symmetry in that shape right there. Now let's look at the next one. I don't know what you call this. Maybe it looks like a weird teardrop or something. And that's it. It just has 1 line of symmetry right down the horizontally down the middle, right? For that one. Now this next shape is the most interesting of all, probably. So we got a circle. I'm gonna give you the center point, right? And let's say there's a line of symmetry. There's a line of symmetry, right? Again, going through the center here. There's a line of symmetry. There's a line of symmetry. And you're probably thinking, Mr. G, when are you going to stop? There's a line of symmetry. When does it end? There's a line of symmetry. So a circle is actually a special shape. It has an infinite. A circle has an infinite number of lines of symmetry. So that one's a special shape there. Awesome. Now, moving on from lines of symmetry, let's talk a little bit about rotational symmetry and what that means. Kind of how I explain this quickly in my class, I tell them, if you can spin the shape, right? Rotation means you're actually spinning the shape, right? See how I'm spinning this? If it ever looks the same as what you started with, then it has rotational symmetry. Now that's before you do a full circle, right? If you do a full circle, or if you do a full circle, then of course everything's going to look the same after doing a full circle, and that does not count as rotational symmetry. So again, looking at this pentagon, if I rotate this pentagon, you see me rotating it, rotating, it'll stop right there. Doesn't that look exactly like what we started with? See this here, right? We got this point up here. We got this point up here. This is the top of the pentagon. But if I rotate it back to how we started with this, right? This is how we started. Look, it's exactly the same, right? So each of these little points here, when you rotate it, should look exactly the same. So there, it looks exactly the same what we started with. There, it looks exactly the same. There, it looks exactly the same. And there, it looks exactly the same, right? And then we're back at the beginning. So this does have rotational symmetry, right? Yes, I'll just put yes to rotational symmetry, right? Just shorthand that to rotational symmetry. As a matter of fact, it has like 4 different points of rotational symmetry, right? There's 4 times that shape maps itself onto itself while rotating it. Whereas this next one, if I were to rotate this shape, right? In my next one, I'm talking about this one right here, right? If I were to rotate my screen here, this is the starting image, looks like this, some weird quadrilateral. As I spin it, it will never look the way it did at the beginning until I've done a full circle. Now it looks exactly like how we started. And so that means this does not have rotational symmetry. No rotational symmetry, right? This next problem is asking us to identify the line of symmetry and rotational symmetry of an equilateral triangle. Now this is a key word. Make sure you remember what equilateral means, right? Equal sides, equal angles. So this triangle is going to look like, I'm going to try the best I can here. Draw that, and that, boom. I'm going to go ahead and put hash marks on here as well, just to kind of show these sides are all congruent, right? All the sides are equal for equilateral triangle, so all the sides are congruent. So where's the lines of symmetry at? I'm going to use this yellow color here. So you should see that there's one here. Should be one here through each. It's going through each point, right? Each tip of the triangle here, each vertex should be a line of symmetry. So it has 3 lines of symmetry. 3 lines of symmetry. But does it have rotational symmetry? Let's look at rotational symmetry real quick. So again, I'm going to start here looking at this point, right? So this is how I see it now. If I rotate my image, does it ever look the same? Does it ever look like how we started? And if you rotate, nope, boom. Let's look here, though. Right now I'm looking at that as my top. And that does look exactly the way it looked as we started. And so you would say, yes, I haven't done a full circle, I haven't done a full 360 here, so this does have rotational symmetry. As a matter of fact, if we kept going, you'll see it happens again right here, right? So there's 2 other points of rotational symmetry here where that happens. And then we do a full circle and get back to the original image. So I'm going to say yes to rotational symmetry. And let's look at this last problem. All right, this is a toughy one. I'm going to go ahead and pause the video and do my T-chart real quick. Okay, so for this last problem, it says describe a congruence transformation. So remember, congruence transformation means a transformation where the shape doesn't change. It may change location, but the shape itself does not change. All the sides and all the angles stay congruent. But we're going to describe a congruence transformation that maps triangle PQR to triangle STU. Now, something that's really important here is we're going from PQR to STU. So that means PQR is actually going to be our pre-image, right? This is our pre-image. We're starting there, and we're going to STU. So STU is going to be our image. And it's easy to see what maps to what, because you just look at the letters. P comes first here, so S comes first here, so P becomes S, right? P maps to S. Q will map to T, and R will map to U, right? So this is how this will map right here. So let's go ahead and I'm going to write these points down in blue right here, S, T, U. I'll pause the video for this real quick. Cool, so those are the points for STU, for our image. So again, what we're trying to do here in this problem, this is a little bit backwards, right? Usually we give you the transformation we want to see, and you show us the rule, you give us the new points for the image. This time, I give you the pre-image, I give you the image, I give you the points for the image. I want you to tell me what is the rule that's used to get those final points, right? So this one's a little bit hard. You kind of have to look and see what's happening here. And the first thing I noticed is I looked and saw that all of the x values here, right? All the x values have a negative sign now, whereas before over here they were positive, right? So the x values are changing sign. X values change sign. So I'm going to put x values change sign here. That means for our rule, we know we're going to have a negative x in there, right? A negative x, okay? Now what's happening to our y values? So you may look at the first one, look at P and S, and you say to yourself, well, it's going from 0, right? If I'm going to look at this y value here, it's going from 0 to negative 5. So it looks like you might be thinking, oh, y minus 5, right? 0 minus 5 is negative 5. But if you go to the next one, you look at negative 3 and negative 2, negative 3 minus 5 is not negative 2. So you know it's not as simple as saying, oh, it's shifting down 5, so y minus 5. It's not what's happening here. What I do, after a while looking at it, after some thinking and looking at it, what you can do is you can say, well, we know that it's this shape over here looks like it's probably doing some kind of rotation. And right, from here to here, so the next quadrant would be a 90-degree rotation. To the quadrant after that would be a 180-degree rotation. So I'm thinking to myself, okay, so negative x, comma, negative y for 180 degrees. That's our rule for a 180-degree rotation. Because I believe a 180-degree rotation is happening. So let's check that out then. If that's the case, then we know that our rule over here is going to have a negative y in it, right? Followed by, what do we think is happening after that? Followed by, because after we do the rotation, if it looks something like, just a rough sketch, something like that, how does it get from here to here, right? That looks like it's sliding, right? It looks like it's probably doing some kind of translation. So I think a translation is happening, but the question is, what is the translation? It's shifting down how many units? Well, now look what's happening. If I have negative y, so all the y values are going to change. 0 becomes negative 0, which is still just 0. And let's go ahead and subtract 5 from that. 0 minus 5 is negative 5, so that works for the first one. What about negative 3? If I plug in negative 3 into this right here, into negative y, well, that's going to be negative 3. And a double negative becomes positive. So it's going to be a positive 3 minus 5. And 3 minus 5 does give us negative 2. So look at that point T, that looks good. Let's look at U then, right? I'm going to look at this negative 4 real quick. Look at this negative 4. If I plug in negative 4 into here, well, negative 4, right? It's going to be a double negative, so it's a positive 4. 4 minus 5 is negative 1. So that works. So then the rule here, so it's followed by a translation, 5 units down, which looks like this, right? The x value stays the same, y minus 5. So when you combine these, right, which the combined version being this right here, I've combined it all into one, the rule that describes this transformation altogether would be a negative x, negative y minus 5. That's our rule. Thank you.